Dear friends, welcome back to my YouTube channel MCBChemTube. This is an online chemistry tutorial you get my previous videos from my personal homepage or from my YouTube channel. And we were discussing about the topic hydroxy compounds, and today's lecture I would like to discuss with you what is acidity of and esterification of alcohol, and oxidation and catalytic dehydrogenation of alcohol. So our learning objectives are to understand the reaction involving the cleavage of O-H bond. That is, we will discuss for example, acidity and esterification for this. And secondly, oxidation of alcohol with some reagents, PCC Collin's reagent, John's reagent, and KMnO4. And third topic is catalytic dehydrogenation process. And first one, the reaction involving the cleavage of OH bond, that is this OH bond. First one, acidity of alcohol. Alcohol can react with base and it form alkoxide ion. Like a hydroxyl proton of water, alcohol behave as weak acid. Hydrogen is attached to oxygen in alcohol, then it attracts, this oxygen attracts a pair of electrons on this OH bond. So the pair of electrons that is residing here can attract towards this oxygen. Hence, there is a tendency to lose the hydrogen as a proton because it is attracting this both electron towards this oxygen. It will lose as H plus proton. In other words, the ability of oxygen to accommodate negative charge. So it has an oxygen has an ability to accommodate the negative charge, the lone pair of electron. Then it make it stabilize. So alcohol with base, it form alkoxide is shown here. For example, ethanol with base, it form methoxide ion. And alcohols are weak acid, does not react with weak bases such as sodium bicarbonate or amine. They do react with alkali metal and strong bases. For example, tertiary butyl alcohol react with the potassium, it form corresponding potassium salt, potassium alkoxide, potassium tertiary butoxide. Methanol with sodium hydride, a base, strong base, it forms sodium methoxide. And similarly, ethanol can react with sodium amide, a very strong base, it forms sodium ethoxide. Corresponding alkoxide, a salt it can form. So in this reaction, we have seen that OH bond cleavage take place. And next one, what is the effect of on acidity of alcohol? Usually acidity vary according to the structure. For example, in here you can see when you go from methanol to tertiary butanol, acidity gets decreased. You can pick a value, get decreased. And any factor that stabilizes the conjugate base will increase the acidity. So what is mean by conjugate base? Actually, alcohol is an acid. When it loses a proton, it forms alkoxide anion, and that is called conjugate base. And any factor that is stabilizing this conjugate base will, that stability shift the equilibrium towards this direction, so more alkoxide will be formed. And coming to acidity of alcohol, highly bulky group in alcohol which inhibit the solvation of conjugate base. And this is alcohol. So when you have there are many factors which determine the acidity of alcohol. One factor is stability of conjugate base can be determined based on solvation of solvation can stabilize the alkoxide ion, of course. So when you consider methanol and tertiary butoxide, you can see that in this methanol or methoxide, this is sterically accessible and less hindered, and more easily this alkoxide can be solvated. But in the case of tertiary butoxide, it is sterically less accessible and more hindered and less easily solvated. So it cannot solvate very easily, the tertiary alkoxide. So it is stabilization is less. That means this will be having less acidity, that you can see here. And the second factor that determines this acidity is inductive effect. So alkyl groups of hindered alcohol. Here you have a 3 alkyl group. All 3 alkyl group is a plus I group. It can donate electron density, and it form more electron density on oxygen. So this is localized, the electron density is localized over one atom. That also can be destabilize this alcohol. And that is, electron donating group can destabilize the conjugate base by localizing the charge on oxygen. And you can see it here. All are electron donating group, so it can increase the electron density over one atom. It can destabilize this conjugate base. And at the same time, electron withdrawing group, you have an CF3 group. All are electron withdrawing, so it can decrease the electron density over one atom and it delocalize over all molecule. Then it can stabilize that alkoxide ion. So electron withdrawing group stabilize the alkoxide and lower the pKa. And electron donating group donate electron density to here, and it can destabilize the conjugate base. So when you have a more electron donating group, it can decrease the acidity. Next one, reaction involving the cleavage of OH bond, esterification of alcohol. Alcohol react with the acid. This you can see it here. Alcohol with the acid in the presence of catalyst concentrated sulfuric acid, it forms ester. This is the general reaction scheme. It is shown here. A specific example is acetic acid with ethanol. In the presence of acid, it forms ethyl acetate. And this esterification reaction is a reversible reaction, that is, you can see it here, and hence it is carried out by in the presence of dehydrating agent. So we have to remove this water, and once it is removed, this water is removed by dehydrating agent, the equilibrium will be shifted towards the product side by Le Chatelier principle. And the mechanism of esterification reaction, in this case, first acid protonated first. This is a nucleophile, and this can protonated by the protic acid, and it make this carbon more electrophilic, and alcohol can act as this hydroxyl group can act as a nucleophile, and it can attack this carbonyl carbon, and it form a tetrahedron geometry. A proton is lost on oxygen. Here in this example, you can see that the proton here, this proton is lost, okay, from this oxygen and move towards this more nucleophilic center, that is hydroxyl group. So, and finally it form a hydronium ion. This is a good living group. This can be leave from here by forming this oxygen lone pair forming a double bond. So this is assisted by the water, and it form a protonated ester, and finally a transfer of proton take place. A transfer of proton to base, it leads to an ester. And in this example also you can see that this is the alcohol part. Here the OH bond is cleavage take place. And the next one, oxidation of alcohol. Primary alcohol on oxidation, it normally yield aldehyde and acid in some cases, and the secondary alcohol it yield keton, and tertiary do not react. So primary alcohol on oxidation, it first give aldehyde, and further it oxidizes to carboxylic acid. It's secondary alcohol that you can see here, it oxidizes to keton. So it cannot further oxidize, it has to cleave for further oxidation process. So what are the reagents that is used to convert this process? One is the PCC, that is pyridinium chlorochromate. Another one is Collin's reagent. Collin's reagent is chromium oxide with pyridine, TC dichloromethane. Third one, John's reagent, that is chromic acid, H2CrO4. Fourth one, and potassium permanganate. And first we will consider pyridinium chlorochromate, PCC. Usually oxidation of aldehyde to acid in aqueous solution is easier. Aldehyde you can convert into acid in aqueous solution, and it is easier than oxidation of primary alcohol to aldehyde, because it is very difficult to stop the reaction at aldehyde. Aldehyde can further oxidize to acid. So there are some excellent reagents used for the conversion of primary alcohol to aldehyde. That is, one is PCC. PCC is prepared by treating chromium trioxide or dissolving it in hydrogen chloride and finally treated with pyridine. So chromium trioxide with HCl with pyridine, it forms pyridinium. This is pyridinium, and chlorochromate. This is pyridinium chlorochromate. And PCC is used to convert alcohol, primary alcohol into aldehyde, propanol into propanol, and this is the another primary alcohol corresponding aldehyde. You can see it here. And also it is used to convert secondary alcohol into ketone. That is, you can see here isopropanol is converted into propanol, and another secondary alcohol converted into corresponding ketone. So primary alcohol yield aldehyde and secondary alcohol yield ketone. And this also can be used for the conversion of alcohol containing double bond. Here the double bonds are unaffected during the oxidation. That is the one advantage of PCC. And next reagent is Collin's reagent, that is chromium oxide with pyridine in dichloromethane. It is also used for the same purpose of to oxidize primary alcohol to aldehyde and secondary alcohol into ketone. And Collin's reagent is a complex which is produced by treating chromium trioxide with pyridine. That is, you can see here, chromium trioxide with 2 pyridine. So it is also used to convert alcohol into aldehyde, that is, you can see here, and secondary alcohol into corresponding ketone. And both PCC and Collin's reagents are used to convert primary alcohol into aldehyde and secondary alcohol into ketone. Please remember that reagent. Next one, oxidation of primary alcohol into acid, CH2OH into CO2H. Primary alcohols are oxidized to acid by potassium permanganate or chromic acid, H2CrO4. So primary alcohol first oxidized to aldehyde and further oxidized to carboxylic acid. Both these reagents are used. And oxidation of the secondary alcohol to acid, usually it gives ketones. So for this conversion you can use secondary alcohols can be converted into ketone by KMnO4 or chromic acid also. And usually reaction stops at the ketone. That is, you can see here, it further does not react. And first, what are the reagents that is used to convert a primary alcohol into acid? One is John's reagent. John's reagents are prepared by dissolving chromium oxide trioxide, CrO3, or potassium dichromate in aqueous sulfuric acid. And 2 ways you can prepare. One is chromium trioxide with aqueous sulfuric acid, it gives H2CrO4, and potassium dichromate also it gives chromic acid. Okay. And the solution of chromic acid in aqueous sulfuric acid is known as John's reagent. And organic compound usually, this is organic compound is usually it is insoluble in water, and acetone is used to make it soluble. and water and acetones are miscible, so it can bring all this reactant and reagent into one medium. So this hexanol can be converted into hexanol, and finally it oxidizes to carboxylic acid, corresponding carboxylic acid. This is another example. Primary alcohol is converting into carboxylic acid by using John's reagent. And at the same time, secondary alcohol is oxidized to ketone. For example, cyclooctanol converted into cyclooctanol by using John's reagent. And another example, menthol, that is 2-isopropyl 5-methyl cyclohexanol, it converted into methanol, corresponding ketone. This is a secondary alcohol. It converted into ketone by using John's reagent. And the last reagent is potassium permanganate. And primary alcohols are oxidized to acid by very strong oxidizing agent KMnO4 very efficiently. And reactions are carried out by strong basic condition which promote greater speed. And substrate sensitive to base can be done at lower pH. So the reaction can be done in either by basic condition or by acidic condition. Usually KMnO4 is decomposed in water under acidic or basic condition, which result in formation of KMnO2. So primary alcohol is converted into corresponding alcohol acid salt with KMnO4, and finally it hydrolyzed to corresponding acid. Okay, and potassium permanganate secondary alcohol are oxidized to ketone, that you can see here. And the reaction rate in basic solution is caused by ionization of alcohol, and this is in basic condition. Alcohol can first ionize to give corresponding alkoxide. This alkoxide is readily transfers electron, and it undergoes oxidation to corresponding carboxylate anion. So this is the summary for chromium based reagent. You can convert primary alcohol into aldehyde by using PCC and Collin's reagent, and you can convert secondary alcohol into ketone by using the same reagent. And to convert primary alcohol into acid, you can use John's reagent and permanganate reagent. And next one is catalytic dehydrogenation of alcohol. Primary alcohols are converted into aldehyde often by catalytic dehydrogenation method rather than using strong oxidizing agent. So ketones are also prepared in this manner. Usually copper catalysts are used. Here primary alcohol with copper catalyst at very high temperature, it gives corresponding aldehyde. Here you can see that dehydrogenation takes place. One hydrogen left from here and one hydrogen left from here, and you get aldehyde. And similarly, secondary alcohol, you get ketone, and two hydrogens are left like this, and it forms ketone. So in summary, we have learned reaction involving the cleavage of O-H bond. That is, one reaction is acidity property of alcohol, another one is esterification property of alcohol. And we also learned oxidation of primary alcohol to aldehyde and secondary alcohol to ketone with PCC and Collin's reagent. Also we have learned oxidation of primary alcohol to acid by using John's reagent and potassium permanganate. Also we have discussed catalytic dehydrogenation of primary alcohol into aldehyde and secondary alcohol into ketone by using copper catalyst. Okay, that's all. Thank you for watching.